Okay, so here is the first version of the EST practice for your Chapter 7 EST. We're just going to go through this problem by problem. I would like you to try the problems on your own first and then use the video to guide you. You can also use the video, watch a few seconds of the problem, and then once you know how to do it, you can then do it on your own. So first, it says here, or actually, I guess I should read these instructions up here. Look at the scatter plots and decide which statement fits each scatter plot. If there is a relationship, then describe it in a sentence. Okay, so actually down below, oh yes, we'll write those down in a sentence. Okay, so first, label if the association is a positive association, a negative association, or has no association. So we're looking at these three graphs here. I want you to pause the video and try to write down which of these has a positive, a negative, or no association. So just like with the line, we see how these points here are generally linear, right? That's their association, and they're going up from left to right. So this here is the positive association. Here, number 2, as you can see here that the points are relatively linear, right? And they have an association where they're all going down from left to right. So this one is the negative association. And then here in this third one, you notice we can't really do anything with, like, I can't really draw any single one line that goes through most of the data. So there's no line of best fit. So there's really no association between these points. They have no relationship. No association. Okay, so now let's start thinking about some problems in context down below. So part A says outdoor temperature and the number of people wearing jackets. So we want to compare if the temperature outside has an effect on the number of people wearing jackets. Well, if it gets colder outside, I feel that more people would be wearing jackets. Okay, so let's say if I were to draw a little XY here, okay, we're trying to see if the number of people wearing jackets, so that would be here, is dependent upon the temperature outside. Well, if I start thinking, so this is, let's say this is 0 degrees all the way to 100 degrees. So as our temperature gets hotter, what happens to the number of people wearing jackets? There's going to be less people outside wearing jackets, right? So let's say if we have a lot of people wearing jackets, let's say this is 50 people wearing jackets, 25 people wearing jackets, and then of course 0 down here. We have a lot of people wearing jackets here. Okay, we want to think about that. Where would they be along the temperature? Would those people be here on the left or over here on the right? Line it up with your temperature. Which one would have the most people wearing jackets? A temperature close to 0 degrees or a temperature close to 100 degrees? Assuming they wore a jacket whenever they were cold, right? Then it would be these points here on the left. There are going to be more people wearing jackets towards 0 degrees. And then as the temperature gets warmer, we can assume that the number of people, these are little people here, the number of people wearing jackets is going to go down drastically, right? So if you see that, this is a negative association. If I were to draw a line of best fit, it's going to be a negative slope there. So this one is negative. So if you wanted to write a sentence, I know there's not too much room here. I think normally you do it on another piece of paper, but we can say as the temperature increases, we're going to say just jackets decrease, which shows it is a negative association. So as the temperature increases, the number of jackets people are wearing, or the number of people wearing jackets, decreases. So that's why it's a negative. So now let's look at this next one. The number of pets a student has at home and his or her grades. Okay, so if we are comparing this, let's look at your grades. Let's say we have student A and student B, and student A has all A's and they have 5 pets. And student B has an F, 2 Ds, and then the rest Cs. So they might be struggling in a few of their classes, right? But they have no pets. Does that mean that if you have more pets, you're going to have better grades, and if you have no pets, you're going to have worse grades? Not at all, right? It does not matter. It does not matter how many pets we have at home versus your grades. So this one is no association. There's no relationship between the two things. One should not affect the other. And just for sake of time, I'm not going to write out all of the sentences because I don't want to make this video too long, but you can definitely write out sentences here. You would say there is no association there is no association between a student's number of pets and their grades. So now let's look at the next one, part C. It says the cost of a person's home and the value of his or her car. So I like to see these things on a graph. Does the cost of someone's home depend on their car? Well, let's just think about it. Let's assume that the more money someone has, the better or the more expensive items they buy. Okay, let's assume that that is a given. The more money somebody has, the more expensive items they buy or they're able to buy, right? So here, if I have a super expensive home, so I'm up here somewhere, if I have a super expensive home, am I going to be driving the oldest car, the most cheapest car? Probably not, right? If I have a really expensive home, like this is like a lot of money up here, not much money, not much money, a lot of money, okay, for how much the car and the home costs, right? So here, if I have a really expensive home, I'm probably not going to have many people here where the home is super expensive, but they have the cheapest car from the lot, right? Like I drove a little Pontiac Bonneville, like whenever I was in high school, because it was just the extra car that my family had, and it was super old. My mom had even driven it in high school, and I was just lucky to have a car to drive to work and to school, right? So somebody who has a super expensive home and somebody who has a super expensive car are probably going to fall in the same boat, okay? So then the least expensive home, the less expensive a home gets, the less expensive their car probably is. And this is not an exact science, this is just estimating. So this appears to have a positive trend. As the cost of somebody's home goes up, the cost of their car is probably going up as well. Alrighty. So now we have someone's age and the number of gray hairs on his or her head. Okay, I'm going to use this diagram, or I'm going to draw another one here. Okay, let's see. So now I have someone's age and the number of gray hairs. You guys have probably given me some gray hairs, and I'm only 26. No, I'm just kidding. So as somebody gets older, what happens to the number of gray hairs on their head if they don't dye it, assuming, right? As somebody gets older over here, they're probably going to have more gray hairs. So the older they are, the more gray hairs they have. The younger they are, the less gray hairs they're going to have. So if you look at that data, this once again is a positive trend here. Okay. What if we were to compare somebody's shoe size and the length of their hair? Well, if I look out in a classroom, right, and I start comparing all of your shoe sizes and then all your hair, the lengths of your hair, is there going to be a relationship between the two? If you have a bigger shoe size, are you going to have longer hair than the person sitting next to you? If they have a smaller shoe size? Not necessarily, right? These two things have we can cut our hair anytime we want. So these two things are no association. We cannot control the size of our feet, but we can cut our hair anytime we want. So those two things, it's not possible to have an association. Okay, so now let's look at your GPA and the number of hours you watch TV per day. So you want to think if a student is, if a student is spending all their time watching TV during the day and they're not spending any time studying or doing their homework, so then they don't do well on tests, they don't have any points for their homework, all that stuff, because you're spending all your time watching TV, what's going to happen to your GPA? So if I were to draw an XY graph right here, just the first quadrant, this is the number of hours you watch TV, and this is your GPA. So the highest GPA you can have is a 4.0, and let's say that the maximum amount of time you can watch TV is 10 hours a day, okay? So the more somebody watches TV, where are they going to fall on the GPA graph there? Do you think they're going to have a high GPA or a low GPA if they spend all their time during the day watching TV? In all reality, if they're not doing their homework, they're not studying for tests, they're probably going to have a low GPA. And then the less hours of TV that's watched, people's GPA is probably increasing, assuming that instead of watching TV, they're studying and they're doing their homework. So if you look here, this one here will have a negative trend because the more TV you watch, the less your GPA is. Your GPA goes down the more TV you watch. So this one is a negative association. So now here we have the amount of time it rained, I should say rained, yesterday, and the water level in the Hanford West parking lot. So if you guys don't know, because I know a lot of us have been home for the past month, like past year really, whenever it rains, our parking lot at Hanford West gets super flooded because it's just, it's like a little, I don't know, it's like a hole and it just gets super flooded. So if it rained yesterday, what's going to happen to the water level in the parking lot? So this is how much it rained, and this is how much rain is in the parking lot, or how much water is in the parking lot. So the more it rains, there's going to be more water in the parking lot. So the more it rains, more water in the parking lot. The less it rains, less water in the parking lot. So you see how those two things create a positive association. The more it rains, the more water there is in the parking lot. So this is positive. Okay, so you're going to need to know how to basically analyze situations such as these and tell me which of these associations it is. Okay? All right, now here we're given a graph. We have to find the slope, y-intercept, and the equation of the line. So I always like to find the the y-intercept first. So I see that I cross my y-axis right here. And this is at 1, 2, 3, 4. Okay, so you always want to make sure you know what it's counting by. So my y-intercept is 0, 2. Now, let's go ahead and write out the general equation of a line. Y equals mx plus b. This is the slope-intercept form. The b here is your y-intercept. Okay? So for our equation, we know that b is a positive 2. Okay? Now let's go and find the slope. For slope, we have to find the rise over run, which actually I'm going to go ahead and move that over here. Slope is rise over run. Okay? So what we need to do is find lattice points and draw slope triangles. So I always like to find all my lattice points. So there's that one, and that one. And then it just kind of gives you options between like which ones you're going to use to draw your slope triangle. So it doesn't really matter what we do here. I'll just go ahead and make a bigger one. And you could have just made the small one here. That would have been fine too. You're still going to get the same slope. So I'm making a big one to show you how you can simplify it if you do make a big slope triangle. So here, my rise, I'm going down 6. So my rise is a negative 6. And my run, I'm going to the right 2 to get to this point here. So it's a positive 2. And this makes sense since my line is going down from left to right. It is a negative slope. Negative 6 divided by 2 is negative 3. So now I know that my slope is negative 3. So then I write my y equals negative 3x plus 2. That is my equation here. And you want to make sure to specify that your slope is -3. Okay, so now here's this one below. So it says, using the graph and trend line below, predict the nightly hours spent watching TV for a person who sleeps for 3 hours a night. So if a person sleeps for 3 hours a night, they will watch blank hours of TV a night. So we know a person sleeping for 3 hours a night. That is not enough sleep, by the way. You want to look here on your graph and see which of the axes are about sleeping. It looks like it's this one here on the y-axis. That's how many hours are spent sleeping. So if it's 3 hours, I'm going to draw a line straight across to my prediction line, or our line of best fit, and then straight down. And that is the estimation that if they only spent 3 hours sleeping, we predict that they spent 6 hours watching TV. Okay? So now let's go and do this one. It says, now predict the nightly hours spent watching TV for a person who sleeps for 1 hour a night. Gosh, that's horrible. I did not make these. Otherwise, I would have said, like, if they watch TV for 1 hour a night, you know? Please sleep way more than 1 or 3 hours a night. So here we're saying, okay, well, what if they sleep just 1 hour a night, right? How many hours of TV does that mean they likely watched? Well, my goodness, if we go across here to our line of best fit, that is 8 hours of TV. 8 hours of TV. That's crazy, right? You can do it the other way as well. So what if we said, okay, I spent 3 hours watching TV. If I spent 3 hours watching TV, how many hours spent sleeping? Okay, you want to look at where it says hours spent watching TV, and here it's 3. So I'm going to go up to my line, and I'm going to go straight across. So if I spent about 3 hours watching TV, then that means I spent about 3 hours sleeping. Okay, so you have to be very careful in reading what is given to you and what they want to know. Okay, so here's another one on finding the slope, y-intercept, and the equation of a line. So once again, the equation of a line, slope-intercept form is y equals mx plus b. And that's because it gives you the slope here, and the y-intercept is the b here. And again, I always like finding the y-intercept first. So in this case, it is 10. So my y-intercept is 0, 10. So my b is plus 10, because it's positive 10. Now for the slope, we know slope is rise over run. So I need to draw some slope triangles. So you see here, this is not a good point to use. That is not a lattice point. But this one here is, and so is this one here. So we can draw a slope triangle, either a big one like this, and then simplify it, or a big one like this, and then simplify that. Or I guess that's a smaller one. Okay? So if I go up and to the right, here is a slope triangle I can use. My rise here is 5. It is not 1. A lot of students say 1 here. But since here along the y-axis, we are counting by 5s. So your rise is 5. Your run, you guys can see down here what we're going by, is 1, 2. So this is your slope, 5 halves, or you can even write this as 2.5 if you were to divide that. But we can leave it as a fraction just so you can see what your rise over run is in fraction form. And this is our equation. So our slope is 5 halves, or you can also write that as 2.5, right? The equation is y equals 5 halves x plus 10. Okay, so hopefully this prepares you for your EST.